The industry's poised for very significant developments this year. We have a perfect storm of two critical elements coming together at the same time. So AI is driving the need for much more compute power, and quantum computing's transitioning from a type of lab experiment into a practical compute resource, increasingly backed by longtime HPC industry players, so making it a little more suitable for the enterprise. Now, the question is, how fast will this all happen? That's the million-dollar question. I mean, it won't be instant. So now, why the excitement and why now? I just wanted to try to put this into perspective. I have about 40 years of experience both in the HPC and in the quantum arenas, not quantum computing, but quantum physics. So in the 70s, late 70s, and throughout the 80s, I worked as a research physicist exploring the dynamics of the upper atmosphere. I worked with global models of the thermosphere and ionosphere that included traditional chemistry and quantum interactions. So back then, much of the work was funded by the Air Force because of its implications on high frequency communication systems. We used an Air Force computer. At Hanscom Air Force Base, we used the CDC computer to run our models. But the really exciting part of the work was when we could go to NCAR, National Center for Atmospheric Research in Boulder, Colorado, with our data and run its massive global model, taking advantage of the facility's Cray computer and the system's vector processing architecture. So back then, access to the Cray and that vector processing technology significantly sped up many a researcher's efforts. And I feel we're in a similar position now with quantum computing, where, as a new technology, it has the potential to speed up certain types of workloads. So there's been a number of recent developments that I think from an enterprise perspective are at least worth looking at now, and they might give us a clue about what's going to happen in the market in the near future. So the first thing, until now, much of the interest in quantum computing was related to cryptographic applications, and specifically its use in breaking codes and securing communications. Now, within the last year, there's been growing interest in using quantum computing to accelerate AI and other demanding compute workloads. So that's one factor why this is becoming more relevant now. Second is that the quantum computing systems themselves are transitioning from what really has been essentially lab experiments to what hopefully will be enterprise-ready solutions. And this will be critical if they're ever going to be used in the enterprise. So, I have a graduate school level of understanding of quantum physics, but my eyes would glaze over when these pure play quantum computing companies would talk about qubit quality and error rates and quantum error correction. What we're seeing now is with some of the major HPC players entering the field, they talk IT and not quantum physics. So that's a good sign for the enterprise adoption. And with that, the interest in quantum computing processing power for AI has driven many of the major HPC solution providers, the companies like NVIDIA, IBM, Microsoft, Cisco, and more, to have some interest in the market. So over the last year, and really in the last few months, we've seen a lot of announcements from these players and others looking at integrating quantum computing into existing HPC environments. So what are the timeframes and what should you expect from an enterprise perspective? So right now, quantum computing is following a very familiar path that many past HPC technologies like clustering, multi-core processors, high-speed memory, high-speed interconnect, and distributed high-performance storage did. So basically, all these technologies were first adopted by the national labs and the large academic supercomputing centers. And once those technologies were proved out in those environments, they eventually made their way into the enterprise. So some see quantum computing following a similar path. And in the last few months, we've seen a lot, I've mentioned there's a lot of examples of national labs and universities partnering with pure play quantum computing companies to integrate that technology into their computing centers. Many of these efforts treat quantum as sort of just another tool in the HPC toolkit to accelerate specific parts of workloads, just as GPUs are used today. So increasingly what you're hearing in these types of efforts are terms like a QPU or a quantum processing unit, and the phrase hybrid quantum HPC environments. So last week, there was a perfect example of this. IBM researchers published a blog describing work they did with RIKEN, Japan's national research and development agency. And the two groups used the full capacity of Japan's Fugaku, I think I said that right, supercomputer with an IBM quantum Heron processor to calculate the electronic structure of a pair of complex iron and sulfur molecules. It's a very sophisticated simulation. But to do this work, they had to develop a closed loop workflow where the supercomputer and the quantum computer processed data separately and fed results back and forth to one another. And this is really, I think it's the first demonstration of a quantum computer and a classical supercomputer working together this tightly at such a large scale. So now what's next? What are the next steps and how do you get started? So I think quantum's path from supercomputer centers to the enterprise won't happen overnight. I mean, we're just seeing trials now in the supercomputer centers, just some basic experiments to get quantum integrated in with traditional supercomputing technology. But for those that are interested in this transition, we should follow what's happening in those labs, but look particularly at how they address the technical and the financial viability of the technology. And with that, some of the issues that are going to have to be addressed and you should be following are, will the quantum systems be able to scale? There are many technical problems that need to be resolved before we see some high capacity enterprise grade quantum solutions. Will the pure play quantum companies that are driving a lot of the developments, will they survive? Like any market, early leaders in a field often have great technology, but from a business perspective, they can't hang in long enough as the market and the technology both mature. We've seen this with so many fields. So let's follow what the major players doing. Will quantum be cost efficient? As I mentioned, we've seen other HPC technologies make their way from the national labs into the enterprise, but some have not. Take InfiniBand. From a technology perspective, it often outperforms Ethernet in HPC environments. So many supercomputing centers use it as its primary interconnect technology. But there are issues that have limited its use in the enterprise. I mean, to start, it costs more than Ethernet. Another factor is that most enterprises don't have the expertise or the time to incorporate InfiniBand into their Ethernet environments. And then aside from that, Ethernet the performance of it is also improving over time. A perfect example is the work of the Ultra Ethernet Consortium. It's called the Ultra Ethernet Standard that optimizes Ethernet for high performance AI and HPC workloads. So in that way, companies get a higher performance interconnect technology without having to go to a new technology. So will that be the case here with quantum? And what I really keep thinking is the ultimate question is, will quantum be necessary? I think it will, but what happens in these markets is an indicator of what we should be looking for. So as quantum develops and the systems become more powerful, so too do the traditional HPC technologies. So we're seeing constant improvements in new CPUs, new GPUs, new high-speed memory. So will these improvements outpace developments in quantum computing? If so, quantum may not be necessary, but that's the question to be resolved. So for CTOs, the best plan of action, I think, is follow what the supercomputing centers around the world are doing with quantum. We'll be covering that, and we'll have quarterly reports on the market in general. For those that want to try out quantum computing now, some of the major cloud providers have essentially quantum as a service offerings that allow you to experiment with quantum computing without that, without the upfront capital investment. And you don't need to hire quantum experts. But it's a really fast moving field right now. Will there be changes this year? Yes. Will they make it into the enterprise? Probably not. But as you can tell, I'm very excited about what's happening. But as following the IT and the HPC industries for a long time and being part of it, I know we need to really critically evaluate the developments in the field before moving to anything new.